Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. Today I'll talk about creating a standalone graphic using TikZ. This is often useful if you have a graphic that takes a long time to compile, or if you want to include the same graphic in multiple documents. In this video, I'll show you how to set up a standalone TikZ graphic document and compile it to create a PDF that you can reuse over and over again that will contain just that graphic. I'll then show you how you can include it in another LaTeX document. I'll also show you how to use the freely available ghostscript tool to convert the output to a PNG file, including the option to have a transparent background. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. I normally do the demos using Overleaf, since this is a freely available online LaTeX editor that doesn't require any setup at all. But today I'm going to be doing the demo using only my local PC, which is running Windows 11. The tools I'll be using today are MikTeX, which is a free LaTeX compiler for Windows, and ghostscript, which is available for Unix, Mac, and Windows. The IDE I'm using is VS Code with the LaTeX Workshop extension. The main reason I'm using this is so that I can convert the graphic to PNG at the end. Most of what I'm doing you could actually do on Overleaf. Here's the basic setup for a standalone TikZ document. The important thing for creating a standalone graphic is using the standalone document class. This will automatically size the output to include only the content of your document, which will be your TikZ figure. Next, we include the TikZ package, since that's what we'll be using to create the graphic. I'm also using the positioning library today, since I'll do a tiny network as our example diagram. Finally, we have the begin and end document environment where we'll put our TikZ code. Now I'm ready to create a simple TikZ graphic. So I'll paste that here, and let's see what we have. It's a very simple network diagram with two nodes, Alice and then Bob, 20 millimeters to the right of the Alice node, and then an edge connecting A and B, or Alice and Bob. I'm using the every node style to make all the nodes circles with a fill of yellow, a minimum size of 15 millimeters, and bold font. I'm also using the every edge style to make all the edges shortened by 2 millimeters on each end and ultra thick. Compiling this code will create a PDF that contains just the graphic. So if I look at the result, I get just this little picture here. So let me zoom in a few times so we can see it better. Here's the result zooming in a few times. One thing you might notice is that the standalone document class really makes a tight bounding box around the image, and it actually cuts off things just a little bit around the edge. So usually with this package, it helps to specify a margin, and you do that up in the document class options. So here I'm going to put in margin equals 5pt, and then I'll save and compile that, and then we'll see that little extra space around the margin. You can adjust that as needed. Now that I have my standalone PDF file, I can include it in another LaTeX document. Here's a LaTeX document that includes the standalone graphic we just created. I'm using the article document class. I'm using full page and parscript for better formatting. I'm using hyperref package to link the author name back to the YouTube channel. These are the usual things. I'm using a package called cleverref for intelligent cross-referencing, because we'll be making some figures and I'll reference those. The key package for our purposes is the GraphicX package, which enables us to include the graphic we just created. In the document body, I have some verbiage here and then a figure. The include graphics command is where I include the PDF file of the standalone graphic, which is called ab.pdf. So let me compile this. I'm actually compiling it twice so that the references are reconciled. Compiling and viewing this, we see that our standalone graphic is included in the document as we see here. Next, I'll show you how to convert the standalone PDF graphic to a PNG file using ghostscript. As I mentioned in the introduction, ghostscript is a freely available tool for working with PostScript and PDF files. You'll need to make sure it's installed and available in your path for what I'm showing you to work. I'm going to open here a terminal, and then I'll paste the command that we need so that you can see what it is. The first part of the command is gswin64c. That's the ghostscript executable on my 64-bit Windows installation. On a Mac OS or Linux system, this command would just be gs. The sDevice option specifies the output format, which in this case is PNG16M for 24-bit color PNG file. The -R option specifies the resolution in dots per inch. I'm using 1200 here, which is really high because I want high quality. This is kind of a small graphic. The -O option specifies the output file name. I'm calling it here ab.png. And the last argument is the input file, which is ab.pdf, which I'm showing here on the right. This was our standalone graphic. So now let's run the command. And so it processes that. And then here's our example output. The result looks pretty good. Let's go back to main.tech and see how this PNG file we just created looks in our LaTeX document. I'm pasting code that's nearly identical to what we had before, except now I'm including the PNG file in the include graphics rather than the PDF. So let's compile that. Here's the result, and it looks great. It looks like a perfect reconstruction of what we were trying to get. One more thing I'll show you is how to create a PNG file with a transparent background using ghostscript. I'll paste the command here. It's identical to what we had before, except one difference is that I am saying that the device is PNG alpha instead of PNG16M. This means it creates a PNG file with an alpha channel, which will make the white background transparent. I also made a different name for the output file so that we can see the difference. So I'll run that. And now let's look at the file that we created, abtransparent.png. And now we see we have this nice looking file and it's transparent background, so it can work great if you want to use it in a PowerPoint or something like that. I think this result looks great. I hope you enjoyed today's episode on creating standalone graphics with TikZ. I will upload everything from today to Overleaf and include a link to that in the show notes. There will be two files. One is called ab.tech. That's the standalone graphic. And the other one that uses the graphic inside a figure is called main.tech. I'll include comments with the ghostscript commands we use today in the file ab.tech. Be aware that the name of the ghostscript executable may vary depending on your operating system and installation. If you found this episode helpful or interesting, please click like or subscribe. If you have TikZ or PGF plots questions, please post them in the comments. If you want to learn more, please check out my other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.